Understanding particle accelerators is crucial before we get into the news. The world's largest and most potent particle accelerator, the Large Hadron Collider LHC run by CERN, is a 17-meter ring of superconducting magnets. It is the height of human scientific achievement. In fact, it is so potent that it can recreate the conditions under which the universe was created. But could this device, which was created to uncover the universe's secrets, hold the key to something much more sinister? CERN was established in 1954 and is one of the most prestigious research organizations in the world, with 23 member states and thousands of scientists. It is a center for cooperation and innovation. Although the LHC is CERN's flagship project, it is just a small portion of an extensive network of experiments and accelerators. Imagine a racecourse for subatomic particles competing against time and space itself, instead of vehicles or horses. Protons are accelerated to almost the speed of light by the LHC, which sends them on a collision course that simulates the energy of the universe at the time of the Big Bang. The collisions produce temperatures that are 1,000,000 times hotter than the sun's core, while sophisticated cooling systems keep the magnets at temperatures lower than those of outer space. The beams inside the LHC are designed to collide at 4 locations around the accelerator ring, which correspond to the positions of 4 particle detectors. CMS Alice and LHCb each have a distinct function in investigating various facets of particle physics, and together they function as enormous cameras. Taking pictures of these collisions after that, researchers search through the rubble for indications of the mysterious along with other events that provide hints about the basic building elements of the world. The Higgs boson is sometimes referred to as the God particle. We may learn more about the macrocosm by examining the microcosm, but every solution raises a new query and presents a new difficulty. The LHC is more than just a scientific tool. It is a monument to human ingenuity and curiosity. It represents our unrelenting quest for knowledge and our aim to comprehend the fundamental forces that form our universe. But as we push the limits of what we currently know, we also need to think about the existential and ethical issues that come up. What are the risks of exploring the unknown? Could our search for knowledge unintentionally reveal forces beyond our control in the sacred corridors of CERN, where the limits of human understanding are continuously pushed? A new discovery has surfaced that makes even the most seasoned scientists shudder. Former CERN researcher Brian Cox, a respected voice in particle physics, recently made a revelation that has both enthralled and alarmed people worldwide. Cox's remarks have an eerie clarity. The huge Hadron Collider at CERN aims to replicate a miniature Big Bang. Yes, you heard correctly. The scientist also discussed the ramifications of this objective, emphasizing the LHC's remarkable potential for generating new discoveries using a small version of the original event that created our universe. This includes its potential to reveal the Higgs boson's secrets and investigate dark matter, an enigmatic material that comprises a sizable amount of the universe. The idea of being able to conjure the very essence of the universe and hold the power of creation in your hands is both exciting and dangerous. The mini Big Bang is more than just a theoretical idea. It is a tangible reality inside the LHC. The temperatures, pressures, and raw energy all resemble the conditions of the universe's infancy. It's like witnessing the birth of existence itself at the dawn of time. However, with such power comes responsibility, and back in 1978, Russian physicist Anatoly Bugarsky was working on the U-7 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, when a malfunction caused his head to inadvertently come into the direct path of a proton beam. The beam passed through his skull with an unfathomable force, entering the back of his head and exiting through his nose. Bugarsky had an unearthly experience when he witnessed a flash that was as brilliant as 1,000 suns. Yet he was pain-free. He stayed awake and even made his way to the clinic for treatment despite the course of the beam leaving a trail of devastation that burnt through bone and flesh. The fallout was both terrifying and intriguing. The incident is not only a personal tragedy but also a warning that highlights the tremendous power and potential danger of particle accelerators. The beam's path caused localized tissue death, which resulted in partial facial paralysis and hearing loss in one ear, but remarkably, Bugarsky's intellectual abilities remained intact, and he continued his scientific career. The possibility of unanticipated reactions is one of the dangers associated with a particle accelerator such as the LHC. Some members of the scientific community have expressed genuine worries about the manipulation or mutation of space and time, which is not the stuff of science fiction. The potential to create a small black hole is one of the most fascinating and concerning issues related to the LHC's experiments. The idea that the LHC could produce a black hole, even on a microscopic scale, is startling to both the general public and experts. Although CERN scientists have assured that any black hole created would be unstable and evaporate almost instantly, the mere possibility has sparked debates, fears, and awe at the power we wield. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, and mysterious entities. It relates to particle accelerators and their basic mechanics. When protons collide at almost the speed of light, so much energy is released that the fabric of spacetime itself is warped. Picture a tight trampoline with a heavy weight dropped on it. The fabric bends and curves, and if the weight is heavy enough, it may create a depression so deep that anything nearby would be drawn into it. That's a crude metaphor for what might occur in the LHC. In the realm of quantum physics, where the laws of the universe are both strange and exquisite, there is a theory that suggests additional dimensions might exist within our reality. If they do, the collisions at the LHC could tap into them, forming a gravitational funnel that would eventually form a microscopic black hole. Some well-known scientists have even taken notice of this mysterious particle dance, most notably the late Stephen Hawking, who in his book forewarned of a scenario in which the Higgs boson could become unstable at extremely high energy levels. This instability could result in a catastrophic vacuum decay, a cosmic event that would wipe out not only the Earth but the entire universe. In his book on the possibilities for mankind, renowned British cosmologist and astronomer Sir Martin Rees also voiced his worries over the experiments carried out at CERN. He examined the possible dangers connected to particle accelerator operations, including those at CERN. His remarks were more than just a warning. They were tinged with existential dread. He described the worst-case scenario, in which a botched experiment might produce a state known as vacuum instability. This instability might theoretically cause a phase transition that would reverberate throughout spacetime, resulting in a cosmic catastrophe that might swallow up the entire universe. Rees's worries went beyond just theoretical reflections. He gave these disastrous consequences a possibility, although a little one, and contended that even that small chance should cause us to stop. The margin of error is very narrow, and the stakes are unthinkably great. The scientists at CERN have calculated the probabilities, run the simulations, and examined the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible exploration, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He emphasized that there are rigorous safety measures in place, extensive reviews and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and so unstable that it would evaporate in a flash of energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of fascination, fear, and even folklore. What exists outside of our reality? Could we unintentionally release unknown forces or entities? How did this notion originate, and what does it represent in the context of scientific investigation? The concept of creating a door to hell has even been sensationalized in the media, adding fuel to the fire of confusion. In string theory of physics, the idea of parallel dimensions is not new. One of the leading candidates for a unified theory of everything suggests that there might be more dimensions to space than the three we are familiar with. These additional dimensions could be compressed or hidden from our perception, but under extreme circumstances, they could theoretically be accessed or revealed. Now, picture the LHC as a cosmic key that opens doors that have been sealed since the beginning of time, when protons collide at energies never before attained on Earth. In theory, this could cause ripples or tears in the fabric of spacetime, creating temporary portals or access points to these hidden realms. While much of this is still confined to science fiction, it's difficult to ignore the weight of possibility. At the center of this debate is the question of responsibility. Should we be tampering with forces that could potentially alter the fabric of reality itself? With the LHC's ability to probe the deepest corners of existence, should we be worried about what we might discover as Brian Cox and other scientists continue to explore the mysteries of the universe? One thing is certain: the pursuit of knowledge comes with risks, and the quest to uncover the unknown is fraught with dangers both seen and unseen. The story of the LHC is more than just a tale of cutting-edge science. It is a narrative of humanity's unquenchable thirst for understanding. And with every experiment, every discovery, the universe reveals itself to us in ever more complex and surprising ways. But the question remains: when we unlock the deepest secrets of the cosmos, are we prepared for the consequences, or will we, like Anatoly Borsky, find ourselves standing at the edge of the unknown, peering into a universe that we may not fully understand or control? The answer to that question lies in the future, one that is filled with both promise and peril. And as we stand on the precipice of discovery, we must ask ourselves, are we truly ready to face what we might unleash?